Hello and welcome to How to R. This is Mike, and today we're going to talk about basic functions and functionality in R. And to start with, we'll begin with some arithmetic operators. So first, just a plus sign. It works. Check it out. There you go. And then the minus sign works as intended. It also does things like division. 6 divided by 2 is indeed 3. You can also raise things, so you can say square pi. There you go. Also, you can use the exponent. So there's the number e. You also can assign variables or objects, and this is important. This is where, this is like the most fundamental part of taking advantage of a scripting language, is assigning variables. And there are a few ways to do that. Give the name, and then the number or object or whatever you're going to assign to that variable. And now if we type in and look at variable 1, it is indeed the value of pi. And so you can say, let's square that. And it comes out just like we expect. There are other ways to assign values. In R, you traditionally see the arrow assignment, but you can use the equal sign. I guess a lot of R people don't think it's quite as cool, but that doesn't really matter as long as it is useful. So you can assign that value. You can also go this way. So let's say you want to do like this. You can make that like that. And let's see if it worked. Variable 3. There you go. 20. So you can assign from left to right, which is less common, but if you want to, go for it. But typically you assign from the right to the left, and that's how you make variables. So how do you make a vector? Well, the first and most basic way is the concatenate function. It's just a C with a parentheses, and so it's important to try, so there you go. So let's see. Let's just go ahead and make this variable. Notice it shows up in our workspace. It's 3 long. It's a numeric variable. And let's look at it. There we go. 1, 2, 3. Another way you can make a vector, which is each item in a vector is called an element. So there are 3 in that one. You can also use what is called a sequence shortcut and just go like this. So we just created a vector of the numbers 1 through 11, just like that. And that's really useful in indexing, so when you want to access certain elements. There's also the repeat function. So say you want to repeat a certain number. Now we're going to repeat, and I'm going to use a tab here to show me what my options are. So x, I'm going to repeat x, and I'm going to repeat it, see, it's going to make it 4. And then you tell it how many times to repeat it. So let's repeat it 7 times. And there you go. You have a vector of 4s. Another way you can make them is the sequence function. And the first option, so I hit tab, and then it goes from a value, so 1, and then comma, and then I hit tab, and I go to 2, and let's say, it's 12. And then there are 2 options. By, so it's the increment, or the number of elements you want it to put out. So let's do first by, and let's say by, 1.333, just for fun. And let's see what it looks like. There you go. So you have a vector that goes from 1 to 12 in increments of 1.33. Now notice it doesn't go above 12. So 12 is the lower limit on that vector. Or upper limit. Yeah. Okay, so in vector, let's see, vec 5. So the other way is to do 1 to 12, and then length out, let's say we want to make it 10 elements long. Then what happens is we get this. There you go. And it does include 12. So the lower limit is 1 and the upper limit is 12, and it goes in increments that make it so that it will be wow. Excuse me. Sorry. Good grief. Yeah. Sunlight just came through my window and made me go crazy. Okay. So it forces it to be 10 elements long, and so it does whatever division it has to do to make it that long. So that's how you make some vectors. Now, how do you index vectors? Well, you name the vector you're trying to index, vector 1, and then you use a set of square brackets, so a first and second square. Now, RStudio automatically creates the second one for you. That's very nice. And in fact, if you delete the first one, while it's still there, just when you first start, it'll delete the second. But if you separate them and then go back and delete, it won't. So that's just a gotcha. Okay, so be careful about that. And then you say which number element you want to access. So vector 1, let's say we want to access the, well, let's do vector 4 and access the third element. And it gives us 3.66. Okay, well, what if we want to look at vector 4 and look at the first through the third elements? We can do that as well. So in element 1 is the number 1, in element 2 is 2.333, and in element 3 is 3.666. Well, not really that many, but all right. So now another way to access elements. Now let's do something here. Let's say we go to vector 4 and we want to access the 23rd through the 24th elements. Oh, look at that. NA. That is a gotcha. And that is because there's nothing there. And so if there's nothing there to access, it'll simply say, sorry, not available. There's nothing there. All right, so another way to access elements in a vector is by using the concatenate function. So let's say we want to do the first, third, and seventh elements of vector 4. Then we put a vector in telling it to do that. And there we go. Those are those elements. There's more magic to this. You can actually access, this is sort of a gotcha, you can access the same element multiple times. And there you go. So we accessed 1 3 times and then the second element. And that's useful, but it can also screw you up if you don't mean to and you do a typo there. And another way, something else that you can do when indexing is negative subscripts. So let's say you want to see all elements except the 4th. Then you hit a negative sign in front of that, and it tells you all of them except the 4th. Notice the 4th here is gone. And you can also do that using vectors. Now let's try 1 through 3. Okay, now watch what happens. It gives you an error. And the reason is because what does this actually look like? Let's highlight it and look at it. -1, 0, 1, 2, 3. Oh, so what it's saying is, look, there is nothing in element 0. That element doesn't exist. Okay, so that means we've got to fix this by wrapping that vector in parentheses, because we meant to say give me everything except elements 1 through 3. But when we hit this negative, it assigned it only to that. It said this created a vector from -1 to 3, but we're trying to negate those elements. So that's a subtle difference, but it's important, because look at the difference in the results, right? 1's an error, and 1 is what we want. Everything is there except the first 3 elements. And you can also negate using the concatenate version of creating a vector. So just put the negative in front, and then say 4, 5, 7, and there we go. Gives us everything else. So lots of great functionality there. Okay, so one last thing for vector indexing is you can do reverse indexing. Let's go from 9 to 1. Oops. It's vector 4. Notice it returns it to you in reverse. And you can also subset. Excuse me. Yep. So there you go. That's reverse. Okay. There's some other stuff that we're going to talk about. And first, let's just see. This is a great way to see if two objects are equivalent. It's called all.equal. And it really checks to see if something is equivalent. So let's create a fifth vector. And let's say C2. Oops. Okay. Now let's see if vector 5 is equal or equivalent, excuse me, not equal, but equivalent is really what it should say, to C222. Now we know it is because we just saw that, but what it'll do is if it is completely equivalent, it will return true. So what happens if we do this? It'll give you a little bit of a difference. So it'll show you that something's different, and that's useful. So what's the difference between that and just doing something like using a relational operator, like a equivalent, like this? Let's say vec5 double equals, which is equivalent, C222. What happens? It does it element-wise, so it's true. The first element's true, the second element's true, and the third element is true. And it also says, well, let's do vec5. Another relational operator is greater than C. Okay, and now notice that none of vector 5 are greater than the second vector. All right, well, what happens if we make it this vector? The first one is true, right? Because vector 5 is just a bunch of, remember, it's just a bunch of 2's. So 2 is greater than 1, but 2 is not greater than 2, and 2 is not greater than 3. And that's what it tells us. True, false, false. And you can do other things like less than or equal to, okay, false, true, true, and so on. You know, greater than, equal to, less than, equal to, all that kind of thing. It's pretty, and there's also a not equal. So vec5, and the not equal is exclamation mark equal. And there we go. So we know that the only ones that are equal are the second one. But remember, this can be confusing because you said, tell me the ones that are not equal. And it is true that the first elements are not equal. And that's the, there's just some little tricky things you got to remember with your logic. All right. So those are some relational operators. Now we're going to talk about making lists. And a list is pretty magical. It's like a vector, except in a vector, each element has to be the same class, and they can only be either a number or a single or a character object. It can't be anything. A list can be anything. So let's do this. Let's put in these 3 vectors and see what happens. We'll call that list 1. So we just created a list. What does it look like? It looks like this. So we have a box. This is, I'll just call it box 1, or element 1 in the list, is a vector of length 3. Element 2 in the list is a vector with 11 items in it, and element 3 is another vector. So this is a list of vectors. But you could have anything in this list. It could be a list with a data frame in it. It could be one element could be a data frame. The next element could be a single number. The next element could be empty. The next element could be a vector. Lists are just really convenient for storing objects in. They are memory intensive, so use them prudently, but they are useful. You can also name the objects in a list. So to do that, you just go like this. Say booyah equals vec1, boom baby equals vec2, and bam equals vec3. So let's create that and let's see what happens. Now notice, instead of it showing you sort of this double bracket to show you that it's the first element, it lists the name. with a $sign out front. And remember, this $sign, what we're going to talk about is how you can access named objects. So there we go. So let's go ahead and talk about that. Let's talk about accessing named objects. Let's look at list 2. And to access something, there's something called list indexing or element name operator. Okay, so this is the element name operator, and you can simply access any element that has a name in an object. So first you start by writing the name of the object in which you want to access something. Okay, then the $sign, which is the element name operator, and then the name of the element. And remember, let's say we want to access the first vector or first element, which we named booyah. So let's go ahead and see what that looks like. It is a vector 1, 2, 3. There you go. And you can also rename. So let's say let's call this list var. We can access elements and then put them as new vectors, or not vectors, excuse me, new variables. So I just took the element BAM out of that list and I called it list var. And now a list var is its own separate object, completely independent of list 2. You can also access elements within elements. I know, it's like a dream within a dream. So, for example, list 2 BAM, and let's access elements 1 through 2. There you go. It's 4 and 4. And you can take those objects, and if you'd like, make those a new variable. Okay, so now I just took those two, and they are now an independent variable all on their own, independent of list 2. So that's important, because if you know how to access named objects, you can make your life a lot easier, because you don't want to have to always use subscripting and all that stuff for accessing objects in your vectors and lists and all sorts of things. Alright, well, that's the end of this tutorial on basic functionality in R. If there's something that I've missed or another gotcha that I missed, please feel free to comment and let me know. You know, if you want to keep getting great updates on this, subscribe, and when I post something new, you'll get notified. And hopefully this has been a happy experience for everyone. So I will see you next time on How to R.